Hi, so this is the first problem on lecture 4 slides under stochastic process. Consider a communication system which transmits the digits 0 and 1 through several stages. At each stage, the probability that the same digits will be received by the next stage as transmitted is 0.75. What is the probability that a 0 that is entered at the first stage is received as 0 by the stage? Okay, so we will assume that the distribution is a stationary distribution. Okay, so we'll construct the transition matrix, probability transition matrix. So for 0 to 0 is 0.75. For 0 to 0 is 0.75, 0 to 1 is 0.25 or 1 minus 0.75. 0 to 0 is 1 to 0 rather is 0.25 and 1 to 1 is 0.75. So we want to find the power of 4 0 0 or the probability from 0 to 0 after 4 bases or states. So the transition matrix P is given by this. So P squared is equal to 0.625, 0.375, 0.375, 0.625. So P2 is the probability that a 0 bit will be 0 for the after or on the third transition, on the second transitions. So 0 to 0 is 0.625, 0 to 1 is 0.375. P4 is equal to P2 times P2, which is equal to 0.53175, 0.46875, and so on. Therefore, the probability that a 0 will be transmitted through 4 stages as a 0 is P to the 400, which is equal to 0.53125. So, furthermore, it is clear that this Markov chain is irreducible and aperiodic. This is P1 times P1. So, by definition of matrix multiplication, it's 0.75 times 0.75 plus 0.25 times 0.25, which is the first element of the resulting matrix, and so on. We have the equations pi 0 plus pi 1 equals 1, pi 0 equals to 0.75 pi 0 plus 0.25 pi 1, pi 1 is 0.25 pi 0 plus 0.75 pi 1. The system can be described by these equations. We have these equations because we assume that it is a stationary distribution. Okay, so we have these equations. So this is the probability transition matrix, and then we have pi 0, pi 1, also pi 0, pi 1. So this is P and pi, and it's equal to pi, or pi times P or P times pi equals to pi. So which describes stationary distribution. So this one, we can solve this by using using octave or reverse octave here. So we have the equations a plus I. So let's go back to the slide. So the equation is pi 0 plus pi 1 equals to 1. Pi 0 plus equals to 0.575 pi 0 plus 0.25 pi 1. Pi 1 equals to 0.25 pi 0 plus 0.75 pi 1. So we will have we have equation 2, 0.25 pi 1 minus minus 0.25 pi 0 equals to 0. And then we have equation 3, 0.25 pi 0 minus 0.25 pi 1 equals to 0. So let's plot it in our octave. So we have so it's 1 1 1 1. Let's put it at the last. Let's use the second equation as the first row of our array. So it's negative 0.25 plus 0.250. Negative 0.25, 0.250. Second array, 0.25 minus 0.250. 0.25, 0.25 minus 0.250. And third is 1 1 1. So let's apply the row reduced echelon form and assign it to B. So we have, for our first variable is 0.5 and second variable 0.5. Thus, the solution of our system of equations is 0.5, 0.5. This means that if data are passed through a large number of stages, the output is independent of the original input, and each digit received is equally likely to be a 0 or 1. This also means that the limit of p raised to n as n approaches infinity is 0.5, 0.5, 0.5, 0.5. Note also that p to the 8 is equal to 0.50195312 and so on. The convergence is rapid. Again, we just have to remember that it is a stationary distribution. I times p is equal to pi. Okay, so that's it for the first problem on stationary distribution, stochastic process.